Good students. On this clip, we're going to be going over an easy way to remember the Pythagorean identities. There are three of them that I'm going to be showing you how to derive. Okay. So let's start out by listing the things you need to have in order to be able to generate these formulas. So basically, what you need are things that you already have come across before. Okay. So the things you need are, let's write them down. Uh, what you need, what you need. You need three things. First of all, you're going to need a right triangle, right triangle, and then you're going to also know, you're also going to need SOHCAHTOA, and last but not the least, you're going to need your Pythagorean theorem, okay, your Pythagorean theorem, okay? So, if you know how to draw a right triangle and label it correctly, using SOHCAHTOA, and then you know your Pythagorean theorem, then you should be in good shape to generate your Pythagorean identities from memory, okay? So what I'm going to do first is I'm going to sketch my right triangle and label it appropriately, okay? So sketch a right triangle right there. So anytime I'm doing using SOHCAHTOA, it has to be with reference to a specific angle. So in this case, let's call this angle right here theta. So the angles for identities are going to be theta. Alright, so if this is theta, then what do I know? I know that the side opposite theta is the side called the opposite, right? So we're going to call it OPP. That's the opposite. Underline O because it's essential for SOHCAHTOA. And then how do we label the other sides? Well, I know that the side opposite the 90-degree angle is always the hypotenuse. So this is a 90-degree angle. The side opposite it is always the longest side. Since this is the biggest angle, this is going to be a hypotenuse. And the other side is your adjacent. Alright? Now, we have a right triangle nicely labeled. And then SOHCAHTOA. What on earth does SOHCAHTOA mean? SOHCAHTOA. What on earth does that mean? Well, it means that sine of theta, of this angle here, theta, is basically the opposite of the hypotenuse. Okay, so sine theta is opposite of our hypotenuse. And cosine of theta is what? Adjacent of a hypotenuse, right? Adjacent for the A, hypotenuse for the H from this triangle. And then tan theta is TOA, opposite of our adjacent. So this is going to be opposite divided by adjacent. Alright? We can also determine the other trig functions from this. There are three other ones, the reciprocal trig functions. So if I reciprocate sine, I'll get cosecant. So cosecant theta is simply the reciprocal of this. So this goes to the top, that goes to the bottom. Cosecant theta is hypotenuse over opposite. If I reciprocate cosine, I get secant. So secant theta is simply hypotenuse over adjacent, which is a consequence of reciprocating this piece. And then if I reciprocate tan, I get a function called cotangent, and cotangent is adjacent over opposite. Alright, so these are the 6 trig functions that can be generated using SOHCAHTOA and its reciprocal. Alright, now the last thing we need to make this come together is your Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Okay? Remember, a and b are the legs, and c squared is always the hypotenuse. So I can use this naming system to label my triangle. So I can call this piece right here, I can call this A, call that B, or I could call this B and A. It doesn't matter, the legs are always the legs, A and B are interchangeable, but the hypotenuse is always C. Okay? Now, with that in mind, I'm going to make an interesting substitution. Since the legs are A and B, I can also use O and A for the legs. And since the hypotenuse is C, I can also use H. So using SOHCAHTOA or OH and A, I can write Pythagorean theorem as a square plus, well, let me, yeah, so a square plus um, plus o square equals h square. Alright, what on earth did I just do? A for adjacent is just a little a, okay? And then O for opposite is this little b, and then C is h squared. So I just made a substitution here, okay? Let me switch this around. I can also write it as O squared plus A squared equals h squared, alright? Using the commutative property of addition, because order doesn't really matter for addition, okay? So O squared plus A squared equals h squared. Okay, so this is Pythagorean theorem, simply using OA and H. Now I'm going to generate the three trig identities, alright? So I'm going to call for identity 1, I'm going to divide by, guess what I'm going to divide by? I'm going to divide by h squared. Okay, I'm going to divide everything by h squared. So starting with, let me underline that so you do not get confused. So starting with what we ended up with, O squared plus A squared equals H squared, which is just the Pythagorean theorem using A, B, and C. I'm going to divide everything by H squared. Let's see what happens. So I divide this by H squared, divide this by H squared, and divide that by H squared. Okay, so what happens here? I'm going to have, on the left side, I'm going to have O over H squared plus A over H squared. H squared over H squared is 1. So from SOHCAHTOA, what is over H? From SOHCAHTOA, I know opposite of a hypotenuse, where I did it here before, opposite of a hypotenuse is sine, right? O over H from SO, and adjacent is cosine A over H. So guess what I'm going to do here? Over H is sine, so I'm going to replace over H with sine squared theta. And then what's A over H? Cosine plus cosine squared theta equals 1. Bam. That goes your first trig identity. Okay? So just by dividing this formula by h squared, you generate the first one. Okay? So the same procedure to generate the other two. So identity 2, I'm just going to divide by a different variable. So identity 2, we're going to divide by, we already have h squared, so now let's use, how about we use o squared? Divide by o squared, divide everything by o squared, okay? So starting with the original Pythagorean version of Pythagorean theorem using a, o, and h, I'm going to rewrite what I ended up with here. O squared plus a squared equals h squared. That's what we had before. Now I'm going to proceed to divide everything by o squared, okay? So divide this by o squared, and o squared. Alright, what does that give me? That gives me 1 plus, and then parenthesis a over o squared equals h over o squared. Or what's adjacent over opposite? Let me just bring this 1 down. Adjacent over opposite is adjacent over opposite is cotangent. That's what adjacent over opposite is. Cotangent, so this is cotangent square. A over O, you can see it right here. Right here we have A over O. Cotangent is A over O. So cotangent square theta equals, what on earth is H over O? H over O is cosecant. So you have hypotenuse over opposite. So cotangent square theta equals cosecant square theta. And voila, there goes our next Pythagorean identity, just by dividing by o squared. Okay? Alright, we have one more. To generate that one, what we just have to do is divide by the last variable, which is a. We divided by h squared to generate this one. Divide by o squared to generate this. So for the Pythagorean identity number 3, identity 3, we're going to divide by a square. Alright, so we'll just do the same procedure that we did in this other two identities. Start with the Pythagorean theorem using O, A, and H. So I'm going to go O squared plus A squared equals H squared. Okay, now I'm going to proceed to divide everything by A squared, and then let's see what happens. A squared, and A squared. Okay, so what does that become? That becomes O over A squared. A squared and A squared is just 1, because they're the same, equals H over A squared. Okay? Now, what is O over A? Remember in TOA, SOHCAHTOA, over A is tan. Okay? So tan is over A, so I can replace this over A squared with tan squared theta. So I'm going to have tan squared theta plus 1 equals, what is H over A? Let's go back here. H over A is the reciprocal of cosine, right? Which is secant. So secant is H over A. So I can replace H over A squared with secant squared theta. And guess what? There goes the third Pythagorean identity. Okay? So bottom line is your Pythagorean theorem and SOHCAHTOA are so powerful you won't really believe it until you see a result like this. So please don't forget your Pythagorean theorem and your SOHCAHTOA, and also how to label it. Thanks so much for paying attention to this presentation. Hopefully it's going to help you remember these three identities. Please subscribe to my video by clicking up here, subscribe to my channel. You can share this video with your friends if you like it on Facebook, Twitter, and Google+. You can like my video here. Just click below here to like it. If you don't like my video, you can send me an email to let me know what issues you had so I can address it in subsequent videos. Okay, so you can also go to my website at mathgotserved.com to watch new videos and also to request videos if you need help in math. Alright, thanks again for watching this presentation. Have a wonderful day.